Hi, I'm Gordon, and this is the third and final video in a series where we're looking at the London Bike Share dataset, and specifically we are looking at simulating bad experiences for customers in the system and getting an idea of how we might optimize this system using bike inventory. If you haven't seen the first two videos yet, I really encourage you to go back. You can follow along, download the data that's necessary and carry out the exact same work that I am here if you're interested. And you'll remember in the last video, what we did was to create a simulation function. And I actually need to specifically call out an error in the code for that function that I wrote. I did not have proper indentation for this function that we wrote. I've corrected it. What you're seeing here now is accurate, but we need to make sure when we're writing these loops that our indentation is appropriately suggesting when certain actions should be carried out. And I did not do that in the last video. Again, what you're seeing on the screen now is correct. So if you're following along, please make the adjustment. It had to do with this block right here, just not being in the right spot. All right. You'll remember that we created using capacity, arrival, and departure rates, a separate data frame as well, right down here. And this is only looking at the 8 o'clock hour. The reason that we're drilling down to the 8 o'clock hour for right now is that there's simply too much information for us to go through every single station at every single hour. At least there's too much information for us to be able to do that very quickly, okay? And if you are interested in ways that we can maybe shorten the runtime on this a little bit, I will just throw out there are certainly ways to make this code a little bit more effective than what I've written here, but what I've written here works for our purposes. We're going to look at what we can get out of a specific time period, okay? So let's go ahead and move forward here. What we're going to be doing now is using the functions that we've already wrote. We're going to actually simulate through and get an idea of what the optimal number of bikes are at each station for the 8 o'clock hour, okay? So we're going to create a loop here, and we're going to iterate through this function data frame that we created. And you're seeing this. Again, it contains arrival rate, departure rate, and capacity. That's all vital information. We need to make sure that it's there. And these objects that I've created, if you need a refresher, they're right up here. A group by got us capacity information, and this arrival rate, departure rate objects, these are simply pointing at certain slices within the departure and arrival data frame that we created before, okay? So we're just going to go ahead and iterate through and say for each station in the function data frame that we created, transposed, to start off, we're going to create some objects that will update as this loop goes. First of all, we're going to just make this assumption at the beginning that we know is wrong, that the optimal number of starting bikes is 0. And that the fewest number of bad experiences possible is some very high number, let's say 1,000. And as we iterate through this loop, we will make it update those assumptions. That will help guide us toward optimization. And to start off, I'm going to create a quick print function here to essentially help us read along with this loop as it goes, okay? So the first thing that we're going to do is print out the station ID, okay? And then a nested loop here is going to allow us to iterate through every possible number of starting bike inventory at each station, okay? So we're already iterating through each station. Now we're going to iterate through all the possibilities for inventory. So for I in range, and we're going to reference the function data frame display the capacity at that station. And we're going to throw in this +1 here simply because of the way that Python starts everything at 0. We want to start at 1. And if you're noticing what I'm doing here, I'll explain this in just a second. We created, or I've created, these lists, and I'm doing this simply so that I can store data that I will refer to later. And just trust me on this one, you'll see the value of this later. But for right now, we're just going to say, okay, at the beginning of this nested loop, we're going to append the arrival rate to this list that we're creating to store all of the arrival rates. We're going to do the same thing for departure rate. Departure data.append. In this case, we'll append the departure value. And we will do the same thing for capacity. And we also want to get bike inventory appended, or the number that we're iterating through here, right? So I, in this case. Append I, fantastic. Now I'm going to create a new list. And these are going to be the results of our simulation. And another loop. And say for simulation in range, and this is how many simulations we're going to do. I'm saying 10,000. And now we're simply going to have to call the function that we wrote previously. So we're going to say the result of each simulation is, and then we call the function station simulation. And when we call it, remember, we have to feed it the information that it needs. So we refer back to our function data frame at this point. And specifically, the station that we are on in that data frame. And as I'm doing this, let me show you the data frame that we're iterating through. I think that might be helpful to visualize. We're iterating through this, a transposed version of this, that is. So each time we go through, we're going through a row of this data frame, right? Okay, and then we're saying, okay, look at every possible level of bike inventory, simulate 10,000 times, the results equal this, and we need to, when we call this function, plug in every bit of information that we told it to look for, arrival rate, departure rate. What came next was bike inventory and then max capacity. So the next item here, bike inventory, is actually going to be I. And finally, capacity at that station. Now, remember that list that we just created up here, set results. We're going to say, okay, go ahead and append the result that we got. And we will do that 10,000 times. Now we're going to jump out of that loop and do something else. I'm going to create a data frame to store this information from the list because the data frame object is simply easier to use. Make a mistake here. There we go. going to call this bad experiences expected. And this data frame, the columns will equal the columns that we specified above. The data will equal our sim results. Okay. Again, we created that above too. And now we need to figure out, this is why I made this a data frame, we need to figure out what the mean is out of all of these total tallied bad experiences per trial. Experiences expected mean. And I'll show you perhaps when we're done here why we need this positional argument in here, but trust me, for right now we do if we want to get the mean number of bad experiences out of this data frame. Okay, and the list that we created up here to store some of our experience data, I'm going to go ahead and append that too. Mean bad experiences. Okay. There we go. Okay, almost done. I'm going to check this condition. If the number of bad experiences, if the mean bad experiences that we recorded, given that number of bikes in inventory, is less than what we assumed previously to be the fewest number of bad experiences possible, then we need to update our assumption about the optimal number of starting bikes and say, okay, well, it must be whatever we're iterating on right now, if it's less than what we assumed before, right? And we also need to then update what the baseline assumption is about the fewest number of bad experiences to say that, okay, well, apparently this isn't the new lowest possible number. And finally, I'm going to throw in some print functions here, and these are going to help us read along with what's going on. Bad experiences. Okay. And we're going to, indentation is important again. We're going to jump, because right now we are right here. We're going to jump out of this loop and back to this one and say, okay, once you get through every station, or excuse me, yes, once you iterate through every possible number of bikes at each station, then you're going to tell us what the optimal number was. Okay. Let's see if we have a typo in here. We may. It looks like we do not. Fantastic. Okay. As this runs, what we're getting is the mean average number of bad experiences across 10,000 trials for, in this case, station 1 at the 8 o'clock hour when it started out with nothing in inventory, then when it started out with one bike in inventory, and so on and so on. And you can see, as you might expect, there's sort of a saddle here where if we start out with no bikes, then there's a higher number of bad experiences expected. And similarly, if we start out with the maximum number of bikes possible, there are a few more bad experiences that you would expect based on random interactions. Somewhere right in the middle is usually the sweet spot, but it does depend on arrival and departure rates. So in this case, it looks like 12, 13, 14 is a good place. One issue with this, as I've written it, is that once it finds, okay, this inventory level yielded 0 bad experiences, it does get stuck on that as an optimal solution. In reality, if we were to do this, maybe 100,000 simulations instead of 10,000, it's more likely that you would see 13 being the optimal number rather than 12. But as we go through, we can certainly see the value of what we've built here, right? And you're going to realize as we go through this how slowly it is moving. For this notebook right here, I don't recall if I have GPU on. It looks like I do not have the GPU on. I would highly recommend having the GPU on if you intend to run this and collect all of the information. I've done this before, and even with GPU on, it can take a couple of hours to actually get, 700 or 800 results from this. And thinking about the size of the data that we're working with, you've got close to 800 or certainly over 700 stations. And, if we're talking going 1 hour at a time, that's many thousands of instances to iterate over. And if you were to drill down even further to like the half-hour increment, you're probably looking at about 35,000 possible combinations to look at. And it takes a very long time for the function as we've written it to go through this. All right, I'm going to go ahead and end the video here. Thanks so much for listening, and I hope this was helpful.